Saurornitholestes. Saurornitholestes, lizard bird thief, is a genus of carnivorous dromaeosaurid theropod dinosaur from the late Cretaceous of Canada, Alberta, United States, Montana, New Mexico, Alabama, North Carolina, and South Carolina. Two species have been named, Saurornitholestes langstoni in 1978 and Saurornitholestes sullivani in 2015. Saurornitholestes was a small bipedal meat-eating dinosaur, equipped with a sickle claw on the foot. Discovery and naming. In 1974, Canadian amateur paleontologist Irene van der Loo discovered the skeleton of a small theropod near Steveville in Alberta. She showed it to John Storer of the Provincial Museum of Alberta, who brought it to the attention of Hans-Dieter Suess. In 1978, Suess named and described the specimen as the type species Saurornitholestes langstoni. The generic name is in reference to the Saurornithoididae, due to the resemblance with this group that is today seen as part of the Troodontidae, and combines their name with the Greek lestes, thief. The specific name honors Juan Langston Jr. The holotype specimen, TMP October 5, 1974, was uncovered in a layer of the Dinosaur Park Formation dating to the late Campanian. It consists of a very fragmentary skeleton including teeth, skull elements, two vertebrae, ribs, tail elements and a part of the hand. Also 3 paratypes were assigned, CMN 12343, CMN 12354, and UA 5283, all frontals. 2 more complete and larger partial skeletons, RTMP 88.121.39 and more 660, dozens of isolated bones, and scores of teeth are today known from the Badlands of Dinosaur Provincial Park in Alberta. Most of these are housed at the Royal Tyrrell Museum of Paleontology, in Drumheller, Alberta and remain undescribed. The Alberta and Montana remains are usually attributed to the single species Saurornitholestes langstoni, though they come from a variety of rock formations indicating a wide span of time. For example, the Oldman Formation, dated to about 77 million years ago, and the Upper Two Medicine Formation, about 72 million years ago. Similar teeth are found in younger deposits, dated to around 70 to 69 million years ago, but whether they represent S. langstoni or a different, related species is unknown. Neonate-sized Saurornitholestes fossils have been reported in the scientific literature. Fragmentary fossils of Saurornitholestes have also been found from the eastern half of North America. A tooth found in the Moorville Chalk of Alabama has been assigned to the genus. In 2015, Schwimmer et al. Identified the existence of Saurornitholestes langstoni from the Tar Heel, Coachman, and Donahoe Creek formations of North and South Carolina based on diagnostic teeth and a pedal ungall. This also makes S. langstoni the only dromaeosaurid taxon reported with certainty from the East Coast. Saurornitholestes sullivani is known from the hunter-wash fauna of the Kirtland Formation in New Mexico, based on the frontal SMPVP 1270. It differs from S. langstoni in the characters of the frontal. A well-preserved skeleton of Saurornitholestes discovered in 2014 is currently under preparation by University of Alberta paleontologists working in Japan. After examining the skull of that specimen, Curry and Evans announced in 2019 that the zapsulous teeth from the Dinosaur Park Formation represented the second premaxillary tooth of S. langstoni. Formerly assigned species. In 2006, Robert Sullivan named and described a second nominal species, Saurornitholestes robustus, based on holotype SMPVP 1955, a left frontal. The specific name refers to the great thickness of this bone, the only trait in which the species is known to differ from S. langstoni. The holotype was found in the Willow Wash fauna of the Kirtland Formation in New Mexico, dated to about 73 million years ago. However, a subsequent overview of dromaeosaurid phylogeny asserted that S. robustus lacked dromaeosaurid characters and should be considered an indeterminate theropod, and a study published in 2014 took the conclusion a step further by demonstrating that S. robustus was assignable to Troodontidae based on similarities with Troodontids. Possible indeterminate fossils are known from the Hell Creek Formation in Montana, North Dakota, and South Dakota, dated to about 66 million years ago. Description. Like other theropods in the Dromaeosauridae, Saurornitholestes had a long, curving, blade-like claw on the second toe. Saurornitholestes was more long-legged and lightly built than other dromaeosaurids such as Velociraptor and Dromaeosaurus. It resembles Velociraptor in having large, fang-like teeth in the front of the jaws. Saurornitholestes most closely resembles Velociraptor, although the precise relationships of the Dromaeosauridae are still relatively poorly understood. Saurornitholestes was about 1.8 meters, 5.9 feet, long and weighed approximately 10 kilograms, 22 pounds. At the hip it stood 0.6 meters, 2 feet, or around as tall as the length of a terrier. Saurornitholestes sullivani is thought to have had a keen sense of smell, due to its skull suggesting an unusually large olfactory bulb. The second premaxillary teeth of, at least, Saurornitholestes, Velociraptor, and Bambiraptor may have been structurally specialized for preening feathers. This may also have been the function of the unusual premaxillary teeth of the Oviraptorosaurs Protarchaeopteryx and Incisivosaurus. Classification. In 1978 Suze assigned Saurornitholestes to the Dromaeosauridae. Later studies most often found it a member of the dromaeosaurid Velociraptorini, but a cladistic analysis by Philip J. Curry in 2009 recovered a position in a more basal dromaeosaurid clade that was named the Saurornitholestini. The cladogram below is the result of a 2019 analysis by Philip J. Curry and David C. Evans. Curry and Evans recovered Saurornitholestes as the sister taxon of Atrociraptor. Paleobiology. In 2001, Bruce Rothschild and others published a study examining evidence for stress fractures and tendon avulsions in theropod dinosaurs and the implications for their behavior. They found that only 2 of the 82 Saurornitholestes foot bones checked for stress fractures actually had them. 2 of the 9 hand bones examined for stress fractures were found to have them. Feeding habits. Saurornitholestes feeding habits were discovered to be typical of coilurosaurian theropods, with a characteristic puncture and pull feeding method. Studies of wear patterns on the teeth of this animal by Angelica Teresa et al. In a study regarding theropod feeding habits indicate that dromaeosaurid teeth share similar wear patterns to those seen in the Tyrannosauridae and Troodontidae, respectively. However, micro-wear on the teeth indicated that Saurornitholestes likely preferred larger prey items than the Troodontids it shared their environment with. Such differentiations in its diet likely allowed the theropod to inhabit the same environment as its more distant Maniraptor and relations. The same study also indicated that both Saurornitholestes and the related Dromaeosaurus, also analyzed in the study, likely included bone in their diet and were better adapted to handle the stresses associated with attacking struggling prey, while Troodontids, equipped with weaker jaws, preyed on softer animals and prey items such as invertebrates and carrion. This feeding strategy and ability to handle struggling prey was also a feature that the Dromaeosaurid also shared with Tyrannosaurids such as Gorgosaurus, which was also analyzed in said study alongside these smaller theropods. Paleoecology. Saurornitholestes was found on both sides of the western interior seaway. Alberta, the location of Saurornitholestes langstoni, had a habitat similar to the United States Middle West, being plains and floodplain swamps. In its eastern range, Saurornitholestes lived alongside hadrosaurs like Eotrichodon and Hypsibema, large theropods like Appalachiosaurus and Dryptosaurus, an unidentified ornithomimosaur, and another unidentified small theropod that was likely either a dromaeosaurid or a troodontid. Saurornitholestes appears to have been the most common small theropod in Dinosaur Provincial Park, and teeth and bones are much more common than those of its more massive contemporary, Dromaeosaurus. Little is known about what it ate and how it lived, but a tooth of Saurornitholestes has been found embedded in the wing bone of a large pterosaur, probably a juvenile Quetzalcoatlus. Because the pterosaur was so much larger than Saurornitholestes, Curry and Jacobson suggest that the theropod was probably scavenging the remains of an already dead animal. Bite marks from Tyrannosaur. Osserole and Jacobson published a description of a Saurornitholestes dentary in 2001. The dentary is about 12 cm long and preserves 15 tooth positions, of which only 10 preserve teeth. 3 tooth marks were visible on the inner lingual surface of the dentary. 2 of the 3 marks are series of grooves made by the serrations on the maker's teeth. The striations are between 37 mm and 40 mm thick with cuboidal cross-sections. The shape of the preserved serrations are too different from those of Saurornitholestes for the marks to be the result of injuries incurred during intraspecific face-biting behaviors. Although the right shape for Dromaeosaurus tooth serrations, the preserved marks are too coarse to have been left by that genus. Although a specific identification cannot be made, the most likely perpetrator would be a juvenile individual of one of the dinosaur park formation's Tyrannosaurids, like Gorgosaurus or Daspletosaurus.